Right. So we're looking at the proportionality question. So the first thing that is very important when you get this type of questions, when you get proportionality questions, is that you want to try and highlight triangles that have parallel lines. As we can see, triangle BFA, there's a line which is parallel to one side of a triangle. So I can apply proportionality theorem on that triangle. We can also see that in triangle CDE, we can see we have a line FG which is parallel to one side of a triangle. Then we can also use proportionality theorem in that small triangle. Now, of course, they've given us two ratios. They've given us the ratio of ADs to DB. So they said that's 5/3, right? And remember, ratios are not length. So I cannot come here and say, well, AD is 5 and DB is 3. Right, so this is going to be incorrect. Why? Because then I'm assuming that the length of DA is 5 and the length of DB is 3, which is incorrect. So they're just saying that now the ratio of AD is to DB, it's 5:3, right? For every 5 parts of DA, there are 3 parts of DB. So I have to introduce a variable. So when it's a variable like this, now it's a length. Now it's a length of DA in terms of K. It's a length of DB in terms of K. So if you divide this 5K in 3K, you will indeed get this ratio. So ratios are not lengths. Now, of course, I'm also given the ratio of BF over FC. Now I'm going to use a different variable. I can use the variable K, right? So they said that's 4:3. So this is going to be 4P. So I'm going to use a variable P is 3P, right? So now they're asking me to find the ratio of CG is to GD. So CG is to GD. Now, what you really want to do that when you get this type of questions, you look at the question. So the question is looking for the ratio of CG is to GD. You ask yourself, what corresponds, which side correspond with CG is to GD? You know that it corresponds with CF is to FE. So that's what you're going to say. You're going to say, well, I know that CG, right, CG is to GD. That ratio is the same as CF, right? So it's the same as CF over FE. And the reason for this is that this is the prop theorem, right? And remember to mention your parallel lines. In this case, parallel lines are FG, which is parallel to ED. Okay. Now, because you know that CG, GD corresponds with CF, FE, and you know that CF is 3P, right? You know that this CF is 3P. Now you have to find this FE also in terms of P. So you have to find this portion in terms of what? In terms of P. So you're going to say, well, I know that FE over FB, well, that's the same as AD over AB, right? And of course, you know that's your what? That's your prop theorem. And in this case, you have to also mention parallel lines. In this case, DE is parallel to AF. So DE is parallel to AF, right? Now remember, you're trying to find FE in terms of P, right? So you know that this FE will be over FB. You know that FB is 4P, right? You were given this FB as 4P. So you know that this will be 4P, which is equal to AD. You know that AD is 5K, right? And AB, you know that AB is this entire length. So in terms of K, that's 8K, right? So this is going to be 8K. Now, if you make FE the subject of the formula, so this is going to be 4P multiplied by 5K over 8K, right? Now, the K's are going to cancel out. So you'll be left with 4 by 5, which is 20, 20 over 8. So the length of FE will be 20 over 8P, so which is 5/2. So 20 over 8, it's 5/2. So this is going to be 5/2P, right? Now, since you know FE in terms of P, right, and you know FC in terms of P, now you can substitute this guy over. So you're going to rewrite this part, right? So we're going to rewrite this part. So we know that CG over GD will be equal to, what is CF? We know that CF is 3P. So this is going to be equal to 3P over FE. What is FE? We know that FE, we just found FE to be 5/2P. So this is going to be 5/2P. Now if you press our calculator, we know that the length of, or rather the ratio of CG over GD will be 6 over 5, right? So this is going to be 6 over 5. So this is going to be what? Your answer for the ratio of CG over GD.